Okay, there's more meat to this last lesson. It's the idea of conditional probability. Sometimes we're interested in the probability an event occurring given that another event has occurred. This is known as conditional probability, as it's the chance of something happening on the condition that another event has happened. So this is what would go on your cheat sheet, but I think there's a way of simplifying this after you've done some exercises. So if A and B are events, then probability of A with a line between it B, what does that mean? That means the probability of A occurring given that B has occurred. You can also read this as the probability of A given B. So I'll give you a moment. And you get that? That's something you can go on your cheat sheet. You get one-sided A4 handwritten note sheet again. Okay, Venn diagram example 1. So conditional probability questions, probably best dealt with Venn diagrams, two-way tables and grids. Example 1, I've got a group of 25 kids, 15 like milk, 17 like iced coffee. 2 students like neither. What does that mean? They don't like either of those two? And 9 students like both. 1 student is randomly selected from the class. We want to find... Well, first we want to draw a Venn diagram to represent the situation. So I might do milk here, iced coffee here. Does someone remember the term used to describe the rectangle? What did that universal said? That's everyone. Well done. I think this example is a bit easier than the maths we did in the last Venn diagram because you're told how many kids liked both. How many kids liked both? 9. Where does that 9 go? In the middle. So we don't need to do as complex maths as before. Also, you know what goes on the outside. 2. And so because you know 15 like milk, to work out how many goes in here, you go 15 take 9, which should be 6. Iced coffee, 17 take 9, which should be 8. But please don't assume that you've done the maths right. Double check. This should add up to 25 if you've done the maths right. 6, 7, 8, 17. 17, is that 25?
Yes.
Yeah. 17 plus 8, 25. You've done the Venn diagram. That's worth marks. B, find the probability that the selected student likes milk. We aren't applying conditions yet. We just want to know if the student likes milk. So the probability likes milk, it doesn't say whether it's a fraction or decimal or anything. 6 over 20. No. Is that... Does it say only likes milk? Do we have a number of kids that like milk and iced coffee? What's it going to be? 15. 15 over 25, so 3 over 5. But C, this is an example that's new for this lesson, probability of likes milk, given that, so it's the vertical line, like iced coffee equals. So the liked iced coffee is the condition applied here. I need to deal with this first. So if they like iced coffee, how many kids like iced coffee in this situation? 17. That's my condition, so it's going to be over 17. The condition has now been applied. Of those 17, how many of them like the milk?
9.
Because that's a little override in the middle. 9 over 17. Is there a number that goes into 9 or 17 nicely? No. So you leave it at that. Okay. Have some moments to get that example down, please. A bit longer because there's a few words there. All right, let's look at the two-way tables example. I'll leave it there so people can grab it. I've got a restaurant owner collecting data on customers. One night, people spent less than $20 dine-in, takeaway, delivery, or they spent at least $20 dine-in, takeaway, or delivery. Find the probability that a randomly selected customer spent at least $20. Can I find that yet? Do I have the numbers I need to do this?
Yeah.
You sure? What is it going to go over? Do I know how many? Is there a number there telling me the total customer? So you need to finish the table like the previous example. So what you do is you go across 12, 17, 9 is going to give you the total that spent less than 20. 31, 15, 13 will give you the total 59. And that's going to give you 38 plus 59. That should be the total customers. But I'm not confident enough yet. I know what I'm doing, but I always like to double check my maths so I can get it right. So if you go vertically as well, so 12 and 31 should confirm this column. 17 and 15 should confirm this column, and 9 and 13 should confirm that. And what should these three along the bottom add up to? They should. So always try to double check it. 97. So you must have done that maths right. Okay, 97 is everyone. So now can I answer the probability of someone spending at least $20? So it's going to be A, probability at least 20. What's that number going to be?
59.
Good. So you chose the right number over the right total. I don't think there's any numbers that go into 59 and 97. Okay. If the question asked you to do it as a decimal, what would you do with the calculator? 59 divided by 97, you'll get a decimal of some sort. B, find the probability that a randomly selected customer spent less than $20 given that they had their meal delivered. So P, spent less than 20 given delivery. So what's the condition here? What do I need to look at first? Is it the spend or is it the delivery? Delivery is the condition. So I'm looking here. My total is 20. And what's going to be on top of that? 9 over 22. 3 doesn't go into either of those. I'm just going to leave it at 9 over 22. So hopefully you're getting practice at this conditional stuff. We'll have one more example after this. Find the probability that a randomly selected customer dined in. So dined in, vertical line, given they spent less than 20. So what am I going to highlight? What's my condition? Is it the dine in or is it less than 20? Less than 20, so I'm looking here. That's my condition. So what's the number it's going to be over? Oh, sorry, I looked at wrong one. My bad. I was just testing. Over 38. And what was the number that I was looking at? 12. Can that cancel down? Yeah, bro, they're even numbers. 6 over 15, 16, 17, 18, 19. I think it stops there. 6 over 19. All right. A few minutes to get that example down. All of these are represented in your tests. And then we'll do one more with a grid. And then you can talk amongst yourselves. Are you poking each other?
No, she pulled my thing.
She pulled your thing, huh?
No.
That's on YouTube now. Your hair tie. Oh, your hair tie.
I was just in a ponytail.
All right, I'd just like to do the last one while you're quiet so you can get your talking out of the way. A pair of dice is rolled. Given that at least one of the dice, so this is a key part here, at least one of the dice shows a 6. Find the probability that the sum of the rolls is 10. So, this is where the difficulty of the test is going to come, is the wording. You need to read it, okay? So it's a grid, and what we're assuming it's a normal dice, so 1 to 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So my grid represents the 2 dice. Each of these dots represents a result, a roll of the 2 dice. But on my grid, based on the question, what is the condition that I'm highlighting? Because the order is different. 6 what? 6 total or 6 was rolled?
Just 1 6 was rolled.
6 was rolled. So someone explain to me, I like that. Okay, you're telling me 6 and 6. What am I going to highlight?
Everything in the 6 lines.
So, okay, my dot is here. Where do I go from here? Do I go up? Up to the 6?
Yeah.
What am I going to colour?
Data.
Yes. What else do I colour? Yes, okay, you get it. That makes me happy then. That is the condition that at least one dice showed a 6. But I'm selecting some stuff from that. The sum of the rolls is 10. What's the only way that you're going to get a roll of 10? 4. So here and here?
2 over 11.
2 out of?
11.
Well done. Why is it not 12?
Because one of them repeats.
Is this repeated here? So you can't double count that, okay? So probability, be careful with writing this as well. Sum of 10, line, the condition is at least 1, 6 equals 2 over 11. That doesn't cancel down. Okay? So a grid example, a two-way table example, and what was the first one? That was a Venn diagram table. This is your homework now. You can do some of that on Wednesday too, because obviously I haven't given you as much time I'm teaching right now.